One of the main and generally regarded physicists of today has recently shared his thoughts on a cutting-edge revelation. Kaku, commonly known for his remarkable contributions to the world of physics, has confirmed that the James Webb Space Telescope has made a shocking discovery: 6 gigantic galaxies that were previously believed to be impossible. This discovery has the potential to significantly expand our understanding of the universe, making it an intriguing development to follow closely. Kaku, a prestigious figure in the scientific community, is of both American and Japanese descent and is an expert in classical experimental physics and quantum mechanics. Unlike more cautious and skeptical scientists, Kaku is open to the extraordinary findings of the James Webb Space Telescope. His willingness to embrace these discoveries brings a refreshing perspective to the discussion, and we're excited that such a renowned scientist has chosen to speak out, sharing what is now undeniable. The enthusiasm and even excitement in Kaku's tone are evident as he discusses the revelations made by the James Webb Space Telescope. He sees this as a pivotal moment in recent times, sparking his deep interest in the field. Join us as we delve into the implications of Kaku's views on the significance of these 6 epic galaxies discovered by the telescope. Michio Kaku has always been a scientist open to exploring new theories and ideas. He recognizes that Einstein's theory of relativity and Newton's laws alone cannot fully explain the complexities of the universe. Kaku believes that the findings of the new telescope have the potential to greatly enhance our scientific understanding, even though many of his peers remain hesitant to accept this viewpoint. This reluctance has sparked concerns and debates among supporters and critics of the Big Bang Theory, as well as those who either endorse or oppose quantum mechanics. Despite these reactions, Kaku remains steadfast, often finding humor in the skepticism surrounding the new discoveries. The James Webb Space Telescope's discovery of 6 massive galaxies, dating back to the earliest moments of the universe, has stunned astronomers. These galaxies contain far more stars than our Milky Way, despite having formed only 700 million years after the Big Bang. The team of astronomers responsible for this groundbreaking discovery has coined the term universe breakers for these extraordinary galaxies, as their existence could fundamentally alter our entire understanding of the cosmos. The new findings challenge the established comprehension of the universe's origins. The Big Bang Theory suggests that following the initial explosion, the universe was in a chaotic and hot state, with the first solid structures taking millions of years to form. It was believed that galaxies, as highly organized structures, formed much later. However, some of the newly discovered galaxies are more massive than the Milky Way, and their immense luminosity suggests they were rapidly forming stars, perhaps hundreds per year, while our galaxy forms stars more sporadically. The precise moment when the first galaxies emerged remains unclear. Until now, research has been unable to determine this, but it has been widely accepted that initially only isolated stars or small groups of stars existed, slowly merging to form larger and larger accumulations, eventually growing into dwarf galaxies. Over time, these smaller galaxies collided with others, increasing in size. According to previous models, such enormous and complex galaxies could not have existed so early in the universe's history. This raises the fascinating possibility that the universe may be much older than previously thought, or that complex galactic structures developed far earlier than assumed. This hypothesis, however, remains difficult for more traditional scientists to accept, and some physics groups strongly reject this discovery, questioning the accuracy of the age estimates. Kaku, fully aware of these challenges, has commented that many outdated and inaccurate theories persist due to the reputations of certain scientists. These outdated models were only debunked once key experiments exposed their flaws. Consequently, the foundation of science, especially in the field of physics, lies with experimentalists who hold theorists accountable. In reality, when it comes to understanding the true origins of the universe, humanity knows very little. The Big Bang Theory was proposed in 1927 based on observations of the expanding universe. These observations suggested that the universe originated from a single point and has been expanding ever since. At that time, The idea of a universe with a beginning and an end was almost impossible for people to grasp, as the notion of an eternally existing universe seemed more plausible. Even today, scientists continue to struggle with fully understanding the true nature of the universe. However, the latest discoveries, while seemingly contradicting the Big Bang theory, should be considered with an open mind. Science has repeatedly shown that progress often comes from re-evaluating old ideas. The acceptance of new theories and discoveries is an essential part of the scientific process. For example, when Einstein was young, people believed that stars and planets were fixed in place within the universe. Now, we know that everything in the cosmos is in motion. Planets orbit stars, stars move within galaxies at incredible speeds, and entire galaxies are hurtling through space at astonishing velocities, their ultimate fate still unknown. Today's scientists are faced with the challenge of accepting uncomfortable truths, recognizing that theories are not absolute and must undergo rigorous testing before being considered valid. The Big Bang theory emerged from the observation that galaxies are moving away from each other, with the speed of their separation proportional to their distance from Earth. This observation, known as Hubble's law, suggested that the universe has been expanding for a long time. Additional supporting evidence came from factors such as cosmic background radiation and the redshift of light from distant galaxies. However, it is important to remember that in the past, people also held incorrect beliefs, such as the idea that the Earth was flat or that the sun revolved around us, beliefs that were supported by the available evidence at the time. It was only through later technological advancements that a clearer and more accurate picture emerged, disproving these assumptions. We are now in a similar situation, where the expectations surrounding the James Webb Space Telescope have not been met with confirmation of the Big Bang, but rather with the discovery of these 6 galaxies, which seemed impossible. This development serves as a reminder that science is constantly evolving and that researchers must remain open to new findings, reconsidering existing theories in light of new evidence. Redshift, a tool used by scientists to measure distances in cosmology, provides insights into the movement of celestial objects. It refers to the change in the wavelength of light as the source moves relative to the observer. For instance, when a car approaches, its engine sounds louder, but as it moves away, the sound fades. The same principle applies to light. When a light source moves toward an observer, it shifts toward the blue end of the spectrum. When it moves away, it shifts toward the red. This phenomenon, known as redshift, has been used to calculate the speeds and distances of celestial objects. However, as scientists analyze the implications of these newly discovered galaxies, the broader conversation about the fundamental nature of the universe is intensifying. If these galaxies truly existed so early in cosmic history, it suggests that our understanding of the timeline of galaxy formation may be incomplete or even incorrect. One of the most pressing questions is whether the universe is older than we previously believed, or if certain physical processes allowed galaxies to form and mature far more quickly than expected. If the latter is true, it may point to unknown mechanisms in the early universe that accelerated star and galaxy formation, potentially reshaping modern astrophysics. Challenging the Big Bang model. The discovery of these massive galaxies so soon after the supposed beginning of the universe directly challenges a key assumption of the Big Bang theory: that matter took hundreds of millions of years to cool and organize into galaxies. If these universe breakers truly existed at such an early stage, then either the process of cosmic evolution was vastly different from our current models, or the timeline itself may be flawed. Some researchers argue that alternative cosmological models should be explored. Could there have been an earlier phase of the universe that we are unaware of? Could the Big Bang itself be part of a larger, more complex cycle of cosmic rebirth? These questions are gaining traction as observational data from the James Webb Space Telescope continues to pour in. The role of dark matter and dark energy. Another avenue of exploration is the role of dark matter and dark energy in this process. These mysterious components make up approximately 95% of the universe, yet their exact nature remains unknown. Could dark matter have played a role in accelerating the formation of these galaxies? Could an early, unknown interaction with dark energy have influenced their rapid growth? If researchers can link these massive early galaxies to the effects of dark matter, it might provide new insights into how structure formed in the universe. However, if current dark matter theories cannot explain this phenomenon, it may mean that our models of dark matter also require revision. A paradigm shift in cosmology? Throughout history, scientific breakthroughs have often forced us to rethink long-held beliefs. The heliocentric model replaced the Earth-centered view of the cosmos. Newton's laws were expanded upon by Einstein's theory of relativity. Now, we may be on the brink of another major shift in our understanding of the universe. Scientists are now faced with a crucial decision. Do they try to fit these findings into the existing framework, or do they consider the possibility that a new model of the universe is needed? Either way, the discoveries made by the James Webb Space Telescope have set the stage for a deeper, more profound understanding of our cosmic origins. What comes next? The next steps involve more detailed observations, cross-verification of data, and new theoretical models to explain these findings. If future data confirms that these galaxies truly existed in the earliest epochs of the universe, scientists will need to revise major aspects of cosmology. Upcoming studies will focus on spectroscopic analysis of the galaxies to determine their precise ages and compositions, comparisons with other cosmic observations to verify the validity of redshift measurements, exploring new physics that could explain rapid galaxy formation. While there is still much uncertainty, one thing is clear. The universe is more mysterious and complex than we ever imagined. Final thoughts. Science thrives on challenges to existing theories. The James Webb Space Telescope's discoveries are pushing the boundaries of what we thought we knew, and whether they ultimately redefine cosmology or simply refine our current models, they mark an exciting new chapter in our quest to understand the universe. The coming years will be crucial in determining the true significance of these findings. As more data emerges, the scientific community and the world eagerly awaits answers to some of the biggest questions in physics. Video as consistently. We urge you to share your contemplations and inquiries in the remarks section. In the event that you partook in the video, remember to like, share it, and subscribe to stay updated with additional content. We appreciate your time and anticipate seeing you in the next video. As we take a gander at these advancements, obviously, the logical scene is moving. The revelation of the 6 gigantic cosmic systems challenges long-held presumptions about the universe's course of events and development. Conventional cosmology, which is focused around the theory of the prehistoric cosmic detonation, has been the predominant system for understanding the beginnings of the universe. That such enormous worlds might have shaped unexpectedly early after the enormous detonation affixes the laid-out account and invites us to re-examine numerous parts of enormous advancement. For a really long time, specialists have been working within the framework that after the huge explosion, the universe was in a high and turbulent state. Over time, it cooled off enough for the first molecules and structures to form. The predominant hypothesis proposed that worlds, which are exceptionally structured and large, could not have appeared so early in the universe's history. Yet, the discovery of these universes challenges this assumption, offering a significant question. Could the universe be older than previously thought? Or perhaps complex structures like galaxies began to form significantly sooner than we believed? This new discovery is not just of interest. It could have significant implications for our understanding of everything, from the basic laws of physics to the structure of the universe itself. Some researchers argue that the speed at which these cosmic systems formed, along with their size, challenges current models of world development. Our current understanding suggests that galaxies formed over billions of years, gradually merging from smaller groups of stars and gas. The idea that such massive and bright galaxies could have formed within the first few 100 million years after the Big Bang is astonishing. This discovery raises a potential paradox. How could such massive and highly organized universes form so quickly in a universe that, according to the Big Bang theory, should have been in a significantly less stable and ordered state? While many analysts remain cautious about this revelation, others embrace it as an opportunity to rethink long-standing assumptions. Michio Kaku himself has pointed out that science is an ever-evolving field where new discoveries can challenge and even overturn past theories. History is full of examples where old ideas, once considered true, were eventually proven wrong. For instance, the geocentric model of the universe was widely accepted for centuries before being replaced by the heliocentric model. Likewise, the discovery of these 6 galaxies by the James Webb Space Telescope could ultimately lead to a major shift in our understanding of the universe. In his comments, Kaku emphasizes the importance of embracing new ideas and staying open to revising old theories. The role of experimental science, especially in physics, is crucial in this process. The work of experimentalists keeps theoretical science grounded in reality. New discoveries like the detection of these galaxies challenge existing models, prompting scientists to reassess their assumptions and adjust their theories accordingly. While many may resist this paradigm shift, Kaku's optimism and openness to change serve as a reminder of the dynamic nature of scientific progress. He encourages others in the field to maintain a sense of curiosity and wonder, understanding that scientific inquiry is driven by a willingness to explore the unknown. Just as we once believed that stars and planets were fixed in place, we now understand that everything in the universe is in motion. The same principle applies to our understanding of the cosmos. Our theories must be flexible, adapting as new data emerges. As we continue to explore the depths of the universe with cutting-edge technologies like the James Webb Space Telescope, it is crucial to remain humble in our understanding and aware of the limitations of our knowledge. The discovery of these 6 massive galaxies is just the beginning of a new chapter in cosmology. It will likely inspire further research and experimentation, and we may one day look back at this moment as a pivotal turning point in our comprehension of the universe's history. The use of redshift as a tool to measure cosmic distances and velocities is one example of how scientists gather data to test their theories. By observing how light shifts due to the motion of celestial objects, astronomers can estimate how far away those objects are and how fast they are moving. This method has been instrumental in our understanding of the expanding universe. However, as we have seen, it is not without its challenges. Small errors in measurements can have significant consequences. As technology advances, new methods for measuring and analyzing cosmic data may emerge. Given the complexities of the universe and the limitations of our current technology, it is essential to remain open-minded and willing to reassess long-held theories. The discovery of these 6 galaxies has raised more questions than answers, yet it also presents an exciting opportunity to explore the cosmos in new ways. Scientists must continue to refine their methods, test their theories, and remain receptive to the possibility that the universe may be far more mysterious and complex than we currently understand. Looking ahead, it is clear that we are on the cusp of a new era in cosmology. The James Webb Space Telescope has already delivered groundbreaking results, and its ongoing discoveries will likely reshape our understanding of the universe. The universe is full of surprises, and as new information comes to light, our knowledge will continue to evolve. Just as past generations of scientists had to let go of outdated beliefs, today's researchers must embrace new ideas and challenge the status quo. The discovery of these 6 massive galaxies serves as a reminder that science is a journey, not a destination. It is a journey that requires curiosity, open-mindedness, and the courage to question even the most widely accepted theories. As we continue to explore the universe, we can only hope for more revelations that will push the boundaries of our understanding.